Hello everyone, my name is Shruti Mahesh Maknikar. I am from Sri Siddheshwar Women's College of Engineering Solapur from Computer Science Engineering branch. Today I am going to talk about the topic dielectrics. Let's start. Dielectrics. Dielectrics are the insulating materials which can store large amount of electric energy and release it under controlled condition. Dielectric material stores charges without actually conducting electricity. These materials in general can be described as materials that are very poor conductor of electric current. For example, glass, rubber, wood, etc. They are basically insulators and contain no free electrons. With respect to atomic view, dielectric materials are classified into two categories, that is polar dielectrics and nonpolar dielectrics. First, let's see polar dielectrics. A polar molecule is one with the in which the center of gravity of the positive charges and negative charges do not coincide. For example, HCl, H2O, H2S, NH3, and many more. The polar molecules have permanent dipole moment due to the non-symmetric structure. These dielectrics having polar molecules are known as polar dielectrics. After that, there's nonpolar dielectrics. When center of gravity of positive and negative charge coincide, the molecule is said to be nonpolar. So, such molecules have zero permanent dipole moment due to symmetrical structure. The dielectrics having nonpolar molecules are known as nonpolar dielectrics. For example, H2, N2, O2. Depending upon the atomic mechanism, there are four types of polarization occur in dielectric materials. First is electronic polarization, second ionic polarization, third orientational polarization, and fourth space charged polarization. Let's see each one of them in detail. Electronic polarization. When dielectric material is put under the external electric field, the electron clouds of atoms, molecules, and ions are displaced with respect to heavy nuclei to a distance less than the dimensions of atoms, molecules, or ions. The electronic polarization set in a very short period of time of the order of 10 raised to minus 14 to 10 raised to minus 15 seconds. It occurs in all dielectrics of any state of ionic polarization. Let's see ionic polarization. Ionic polarization occurs due to displacement of ions under the action of external electric field, which gives rise to a net dipole moment in ionic crystal. It has been observed that dipole moment of ionic materials due to ionic polarization is directly proportional to the applied electric field. After this, there's next one is orientational polarization. Orientational polarization occurs in polar dielectric which have permanent dipole moment. In absence of electronic field, these dipole moments are oriented in different direction. Hence, net dipole moment is zero. However, in presence of electric field, a torque is exerted on the dipole and it will align in the direction of electric field and the dielectric gets polarized. Here, after that, there's space charged polarization. You can see in this picture there's a representation of space charged polarization in which there are some mobile charge and fixed charge. Without applying, at first image, we can see there's a position of that electrodes without applying external electric field. Once the external electric field is get applied, there is a accumulation of charge on the cathode and ions and both electrodes, that the molecules or charges will align in the same direction of that electrodes. This is how we have completed our topic dielectrics. Thank you for watching.